Namaskar, my dear friends. So we have already seen the design and detail of this particular linear battery charger IC. This is very popular battery charger IC which is BQ25171-Q1. So Q1 means it is automotive grade as well. Okay. So in this session, what we'll try to understand is we'll try to implement one of the design of one cell lithium ferrum phosphate battery charger. So this is the complete circuit that we will be discussing, and we will also see how to design this particular values and what are the different things that we need to take care in our mind. Okay. So this is the particular IC that we are going to use, and this is the implementation of battery charger using linear battery charger that we'll be seeing in this session. And this is our input connector, this is our output connector, and this is the status pin. These are the three resistors that are used to set the current setting, like what is the current output or how much current should be there for the charging the battery, like charge current, and what should be the charge timer, what should be the voltage setting, like how much voltage should be there at the output of the battery to charge the battery. So all these things we'll try to understand one by one. Okay. So first of all, we have to understand what is the design requirement, like what are the things that we need to take care of, and then we will land up into the design. So this is the particular implementation that will be the result of this particular discussion. Okay. So let us directly jump into the design requirement and all those things. So we'll go into one cell lithium ferrum phosphate charger design. So this is the application, like example that was given from Texas Instrument itself, and they have like considered some of the design requirements. What is the design requirement that they have considered? The supply voltage that they have considered is 5 volt, and then we have battery which is single cell lithium ferrum phosphate. Then we have fast charge current, that is charge current is 500 milliampere, that is set. What I have done is I have utilized 510 milliampere in my design, and the charge voltage is set to V regulated voltage is 3.6 volt. So this can be always set to like a 3.5 volt, 3.6 volt, or 3.7 volt. Three settings are there for one cell lithium ferrum phosphate. So any of these 3 volt you can set it using the voltage setting of the like resistor. Coming back to charge safety timer, so charge safety timer, the requirement we'll put it as 5 hours itself, like after 5 hours whether the battery is charged or not, we will disable the charging. Similar to that, termination current is actually 10% of charging current, which is going to be, if it is 500 milliamperes, so 500 milliamperes, 10% of that is 50 milliamperes. So here it will become 51 milliamperes. Similar to that, pre-charge current will become 20% of that, which is going to be 102 milliamperes of my fast charge current, which is 510 milliamperes. Okay. We have considered that battery has one NTC, which is inbuilt NTC, 10 kilo ohm. If it is not available, then also we have given a situation of using external 10 kilo ohm resistor, which will be utilized at TSP. Okay. And if you do not want to use the functionality of like temperature sense, then you can utilize this concept. Okay. So with these particular design requirements, let's get into the circuit. So this is the circuit that is implemented. Okay. So this is the input connector that I have taken. This input connector is taken from Worth Electronics. It is 2.5 mm pitch. Okay. And this is a very good connector. And this is the input voltage. So input voltage, you can give it through your USB, or like even if you want, you can give a 5 volt adapter. If you want, you can increase the input voltage to like even 9 volt also, or even 12 volt also. So whichever voltage you want, you can give it. Okay. Coming back to these 10 two capacitors are used at the input. So they are acting as like I mean noise suppression capacitors or filter capacitors. So zero point 0.1 microfarad is filter capacitor kind of thing. And I'll give you the bill of material for this complete design as well. Okay. Coming back to like I set. So I set is set, like charge current is set by this particular resistor R1, which is set to 590 ohm. This, there is a calculation that I'll show you just now after discussing this. So 590 ohm will set the output current to 510 milliamperes. Okay, that I'll tell you. Coming back to charge safety timer, so if you put it 100 kilo ohm, then it will set to 5 hours. Okay. And similar to that, at 2 kilo ohm, if you put to V set, then it will set the output voltage, charge voltage to 3.6 volt. Okay. Now coming back to this output side. So output side you have the battery. Okay, so you connect battery directly here, which is connected here. Okay, you can see here, and this connector can be utilized to connect it to the system. Okay, so you have the system, or generally this kind of battery charger for like one cell lithium ferrum phosphate are used generally in telematic unit, or keyless entries or somewhere. So these are very good battery charger ICs for a small applications. Okay, coming back to a status pin. So we have two status pin. One is like fault indication, one is like charging indication, whether charging is full or charging is happening or something like that. So I have utilized output voltage itself to drive these LEDs, green LED and red LEDs. Why? Because the reason is output voltage is limited to 3.7 volt, right? 3.5 volt to 3.7 volt max. Okay, so these LEDs will not get damaged. So this is the reason V out itself is used to drive these LEDs. Okay, coming back to battery and NTC. So battery and NTC is like one package completely. And if you do not want to use NTC feature, then you can ground this TS pin through a 10 kilo ohm resistor. So 10 kilo ohm resistor is made not used so that you can utilize the temperature safety features. Okay, good. With this, what we'll do is we'll go into design equation directly through Excel sheet. So let me just open the Excel sheet. As you can see, we have a charge current setting factor, which is K I set, which is actually 300 ampere ohm, which is given in the data sheet. Let us say my I set is 510 milliampere, as I was mentioning. So you can see my R I set is close to 588 ohm or 590 ohm we have taken. Okay, so this is what we have done. Coming back to charging chemistry and safety timer setting. So charge timer setting will be taken from table 7.1. So coming back to 7.1 table, so we have 7.1 table here, and you can see we have lithium ferrum phosphate battery. So if you put 82 kilo ohm, then Li plus batteries will give you 10 hours, and if you put 100 kilo ohm, then it will give you 5 hours. Okay, so what I'll do is I will go and put it to charge safety timers to 100 kilo. Got it? Similar to that, V setting. V setting will be set by V set resistors. V set resistor is put 82 kilo ohm. Why? It can be taken from table 7.2. So table 7.2 is V set pin resistor values. So what will happen is we have one cell lithium ferrum phosphate. If you want to put 3.5 volt at charging voltage, okay, then you have to utilize 100 kilo ohm. If you want to use 3.6 volt, then you have to utilize 82 kilo ohm. Okay, so if our aim is to set the charge voltage like we set to 3.6 volts, that's the reason we are going to use 82 kilo ohm. Okay, so this is how we have utilized completely. So got it. With this, we have understood what are the different values of resistors for different parameters of I set or V set and charge safety timers. Okay. Now let me tell you one more thing. What we can do is, let us say we want 300 milliamperes current charging. Okay. So for that case, what you have to do? You have to make it 1 kilo ohm at the RI set. Like current setting resistor will be changed to 1 kilo ohm. Similar to that, if you want to set the battery V set, that is charging voltage to 3.7 volt, then what will happen? For 3.7 ohm, you have to utilize 62 kilo ohm. Okay, so this resistor will be changed to 62 kilo ohm. And similar to that, if you want to utilize charge safety timer to 10 hours, okay, let us say this will be 62 kilo ohm for 3.7 volt. And if I want to use 10 hours, then I have to utilize 82 kilo ohm chemistry, charging chemistry. So if you go into table 2, okay, table 2, sorry, charge chemistry timer setting, then you can see for 82 kilo ohm, we have charge safety timer set to 10 kilo. Got it? So this is how we are going to set it. So with this, what we can do, if you want to set that those values, then for 300 milliamperes and 3.7 volt and 10 hours of charging, these three values will be changed to 1 kilo ohm, and then this chemistry timer will be changed to 82 kilo ohm, and reset will be changed to 62 kilo ohm. So this is how you have an understanding of changing your charging current, your output voltage settings, or your charge safety timer settings, all these things. This is how you do this. Okay. So you can take a screenshot of this for different value set of parameters. How do you want to change the uh, parameters or the values of these resistor settings? Okay. Coming back to these resistors, so these resistors also based on the current that you are using for the diodes, you can utilize some other values of resistors. So generally 470 ohm will be optimal values for both the like LEDs. Okay, 3.3K will make very dim, like it will be very light. If you want to make it little bright LEDs, then you have to reduce the resistor values, and so that's the reason I have utilized 470. So I have pasted the design equation here. You can take a screenshot of this and make use of this in your design. Now let us move to the bill of material. So bill of material, I will just explain you from the Excel sheet itself. So this is the complete bill of material for this particular design. So we have two resistors or two capacitors of C1 and C4, which is zero point 0.1 microfarad from Samsung Electromechanics. Two capacitor 10 microfarad. Okay, we have green and red LEDs from Worth Electronics I have taken. We have two connectors, two pin connectors, that is also from Worth Electronics, and these resistors are there which has been used here. Okay, one 470 ohm you can utilize. I can give you the part number for that as well if you want to change these values of R4 and R5. Okay, and we have one Texas Instrument battery charger IC, which is a linear battery charger IC, which can give you a current output of up to 800 milliampere that we have already seen in our design and detail sessions. Alright guys, so if you do have any questions regarding this design process of this particular one cell lithium ferrum phosphate battery charger IC using linear battery charger, please let me know your queries in the comment box, and which I will be able to answer you out. Thank you so much.